Imagine you're floating in a spaceship, drifting closer to something so dark you can barely tell it's there. No light escapes it, no sound, just a perfect black circle against the stars. You're about to fall into a black hole. What actually happens next? First, you need to understand what a black hole really is. It's not a hole in the normal sense. It's a region of space where gravity has become so strong that nothing, not even light, can escape it. Think of gravity as a slope. The more mass something has, the steeper the slope around it gets. A black hole's slope is so steep, it curves back on itself completely. Once you cross a certain point, there's no slope steep enough to climb back out. That point has a name. It's called the event horizon. It's not a physical surface. You wouldn't feel anything as you crossed it. There's no wall, no barrier, no flash of light. You would simply cross an invisible line in space, and after that, turning back would be impossible. Astrophysicist Karl Schwarzschild first calculated this boundary mathematically back in 1916, just months after Einstein published his theory of general relativity. He worked it out while serving on the front lines of World War I. He died shortly after, but his equations still define the black hole's edge today. So what happens to you physically as you fall in? This is where things get strange. Gravity doesn't pull evenly across your whole body. Your feet, if you're falling feet first, are closer to the black hole than your head. That means gravity pulls harder on your feet than on your head. The difference stretches you. Scientists actually call this effect spaghettification. Your body gets pulled longer and thinner, like dough being stretched by hand. Near a small black hole, this stretching would kill you long before you ever reach the center. But here's a strange twist. Near a supermassive black hole, like the one at the center of our galaxy, the stretching is gentler because the object is so much larger. You could theoretically cross the event horizon of a supermassive black hole without being torn apart immediately. What would you see in those final moments? Time itself starts behaving differently near a black hole. The closer you get, the slower time appears to move, at least from the perspective of someone watching you from far away. To an outside observer, you would appear to slow down more and more as you approach the event horizon, your image growing dimmer and redder, until you seem to freeze there forever, never quite crossing. But from your own perspective, inside the ship, time would feel completely normal. You would cross the event horizon in what felt like an ordinary instant. Two versions of the same event, both true, depending on where you're standing. That's not a flaw in the math. It's one of the strangest confirmed predictions of general relativity. What's actually at the center? This is where even physicists run out of certain answers. According to the equations, all the matter that falls into a black hole gets crushed down into a single point of infinite density, called a singularity. At that point, the normal laws of physics break down entirely. Space and time as we understand them stop making sense. Nobody has ever observed a singularity directly, and many physicists suspect that once we fully understand gravity at the quantum level, something other than an infinite point will explain it. For now, the singularity remains a placeholder for what we don't yet know. Here's a common misconception worth clearing up. Many people imagine a black hole as a cosmic vacuum cleaner, sucking up everything nearby, planets, stars, entire galaxies. That's not accurate. A black hole's gravity works exactly the same way any object's gravity does, based on its mass and your distance from it. If our sun were somehow replaced with a black hole of equal mass, Earth wouldn't get sucked in. It would keep orbiting exactly as it does now, just without sunlight. You only get pulled in if you get dangerously close, well within the black hole's immediate neighborhood. From a safe distance, A black hole is just another massive object in space, quietly obeying the same gravity that keeps you standing on the ground right now. Black holes also aren't purely destructive. In 2019, scientists released the first ever direct image of one, the supermassive black hole at the center of the galaxy M87, captured by the Event Horizon Telescope, a global network of radio dishes working together as one giant instrument. That image confirmed decades of theoretical predictions and showed the world, for the first time, the glowing ring of matter swirling just outside an event horizon. So if you fell into a black hole, what would really happen? You'd cross an invisible boundary with no warning. Your body would stretch under the imbalance of gravity's pull. Time would twist and diverge between your experience and everyone watching from outside. And at the center, you'd meet a mystery that physics hasn't fully solved yet. It's not a monster lurking in space, waiting to devour anything nearby. It's a place where the universe's own rules get pushed to their absolute limit, and where our best equations finally admit they don't have all the answers. That mysterious dark circle in the sky isn't empty. It's the edge of everything we know.